Hey everyone, welcome to another lecture. And today we are continuing over the project that we left, and we will be completing it in days. Okay, we'll take around 5, 6, 7 days. I don't know, a week or 2 week, and I will complete it. And I will complete it. As I said that I will take it to end to end. Okay, it will be a end to end project. Okay, till deployment. Okay, and I'll be keeping it very transparent as I could. Okay. So yeah, and yeah, wait, yeah. So this is the code where I'm coding actually, and this is the project that we were doing, the Miami project. Okay, and I'm continuing it. So the thing that I have left many things. Okay, and I won't be using only single that I'm also doing SVM also. Okay, right now I'm also learning the wait SVM. Okay, so I'll be also using it, and I'll be doing mainly experiment with SVM, that how could we use in a linear project. Okay, it is actually a linear predicting project where we'll use SVM and the linear regression thing, that how do we use it actually. Okay, and using other algorithms also, so that will be a fun. And I'll be also taking many helps, like a lot of helps from the GPT, and I'll be explaining you what I have got it. Okay, so this is the project and we have done a lot of things still here. The first thing that we have left, okay, yeah, so we got our score, which is 1, which is not possible. Okay, this is not also a good thing that we can get a good project, or a score to 1, which is not a good idea. Okay, so now what we'll do is that, why is this like this, man? Wait, should I refresh this? Yeah, and yeah, man, last I uploaded it 12 days ago. Like it is a long time. Wait, what happened? My internet is gone or what?
12 seconds later.
Okay, yeah. So I think it has been fixed, and let's continue our project at 9th August. Okay, last video I uploaded was on 9th August, and yeah, it's pretty late, man. But yeah, I need to keep myself accountable, and that is the thing. So what is the thing that I've done till right now is, let me run all. Yeah. So I've imported libraries, all this thing that we have done, all these things, done, done. Yeah, okay. So there were a lot of things that I haven't done, like the correlation matrix. Okay. And first, let me tell you that what I will do right now. Okay. The things that I want to do today. Okay. So first thing is getting a good data. Okay. The first thing is filtered data. Okay, it is a very important thing. And the second thing we will do is, let me see, it could be, I've used all those things. And yeah, first thing that we will do is like splitting the data. Okay, pre-processed data, and splitting the data into training, and testing data. Testing and validation data. Okay, these are the things that we have to do right now. Okay, and after training, validation, and all those things, we'll use these data, like the training, testing, and the validation data for overall the model. And how is it used? Basically, the training is used for training the model, and the validation set is actually for getting the score or the prediction, and the testing is for the main evaluation. Okay, where we are actually taking a unseen data, and we are doing the evaluation of the model, that how well this model is predicted. Okay, okay, so let's move ahead and let's see what we have done. Yeah, So as we know that we have to predict our sales price, and we have taken also here our the sales price, and this is our uh, cell where actually we are splitting the data, and this is our this is the place where actually we are training our model, and here we are actually predicting, okay, and we are getting our scores like this and the model score and all those things. Now so we'll take the sklearn matrices for the R2 score, the RMSC, the MAE, and all those things for checking the the prediction that our model made. Yep. Okay. So sklearn matrices. Okay. So sklearn dot matrices for regression. Okay. For regression. So let's go there and let's check what the things that we have that we can use for our model. Okay. So for the regression okay, so yeah man, there for the regression we have here. So for the regression what we can do is like we can check our R2 score, okay, and do we have anything else? Yes, we can do also the mean squared error, okay, mean squared error, RMSC, and all those things. So these were the things, and let's ask about the matrices for regression, okay, in the sklearn, like yeah. So this is telling me mean absolute, we know that mean absolute error. Then the second would be R2 score or RMSC, root mean squared error. Yes, mean squared error. Then we will have our RMSC, yeah, RMSC, then R2 score. Yes, R2 score. Yeah. Okay. Adjusted R square. Okay. Mean absolute percentage error. I didn't know about this. Got to know about this thing. And mean bias deviation. Okay, I didn't know about this also. And explained variable score. Okay. Now moving ahead. Relative absolute error. I know about this, man. Like I haven't used it ever. But yeah. Relative squared error. RSC. Okay. It has the formula. We have been given the total formula. Okay. Yeah. So which should we use? Okay. So I know that I have to use R2. Okay. MSC or RMSC, then MAE. Okay. This is the most typical that we use actually for getting the score. But let's see, according to the GPT, what we have been told. So, which we use for the evaluation for checking the score. Okay, stable, ME, okay, RMC, okay, modify, okay. There are a lot of things, man. Like it's not only about like just using the model, but choosing a right, the scoring or the evaluation metric for your model, MBD, and all those things. Okay, learn dot matrices import R2. What do we have? R, wait, no, not, do we have R2 score mean? We're not getting it, man. Why we're not getting it? Mean squared error. Let's see. Like I think I haven't run all yet. Okay. We have got from sklearn. Sorry, from sklearn. I'm a dumb man. So R2 score mean squared error, mean absolute error. We have mean absolute error, root mean square error. Mean square error. Or for the root, we will actually use its power by half. It could be that also. Okay. So let's print our scores. Okay, and I was saying that why are we doing in this, like actually we're not doing it. Okay, we're just exploring it and we're doing it in a very temporary way. Okay, as I said earlier, I am doing just Jupyter notebook. I'm using Jupyter notebook for, just for temporary, for exploring just only. Once I got all these things, okay, I will move to the modular, okay, modular format, or you could say the files format. Why is it not? Yeah, files, in which we'll have, for every step we will have our own Python file, in which will be for the pre-processing all this thing. If you haven't watched the previous lecture, go and watch it. You will be getting more, things about that what I'm doing right now. And not this. Yeah, this is the thing that we have to do. Okay, and if I see the project, man, then I have to prepare actually a very good, a readme that actually helps to know that what this project looks like actually. Okay, because as I have done here also, but I don't want to use my own computer power. Okay, I don't use to my machine computational power. I want to use the cloud and all this thing, because why should not I why should not I use the thing that are free? Okay, so that thing and assumption, all those things I have actually made, pipelines, models, readme, and all those things. I just have to be consistent. Okay, I'm making a project in a good manner, because this is a very starting. Okay, this is a very starting a project in which I have to just make the piece. Okay, and learning from my mistakes and showing all you guys that yeah, I also make mistakes and I don't even know a lot of things. Okay, so print R2 score, R2 score, and our R2 score will be R2, wait, R not, man, R2 score, in which the first parameter will be our x test and y pred. Okay, no, we have got error. Which input to give, man? Like I don't even know sometimes. Why true? Okay, sorry, I'm a dumb man. Like why should we give actually x test? X test is for the prediction. I should give y. Man, I'm dumb also actually. Yeah, so I got our R2 score, and what does R2 score tells about? What if does higher R2 score means a good model or not? Let's ask it. Yes, higher score indicated better, but there are some instances R2 score. Okay, so 0 to 1. So we have around 0 to 1. Close to 100 case model, a large portion of variance in the target variable, which usually measure a model. Okay. Okay, there are a lot of things. Let it tell what it tells. Okay, now we are doing our other things, which are mean squared error. So I'll be using it just MSC and not. So it will be R2 score. It will be much better. Then mean squared error, mean absolute, no, mean squared error. Okay, not mean absolute error, mean squared error. Y test and Y pred. Then we will print, because what I'm doing right now is just copy pasting all those things. Okay, MAE, and it will be mean absolute error. Error. Let's print it. Oh, sorry. Yeah. Okay. So our mean squared error is 3, 4. This is this much, and mean absolute is this. So yeah, this will be definitely high, cause that it is the, it is the square of the errors that we have. Okay, it is the square of the error that we have. So we have a very higher MSE and we need to actually minimize it. Okay, these are the things that we have to do. Okay, and so this is the thing that we have to do. Okay, now moving ahead, and now what I will do actually is that I will split the data. Okay, as we have the good data. Okay, the new data without outliers. We have a good data, and now using this data, we'll split the data. Okay, so we will, let me clear this all. Wait, I will split the data. Okay, splitting the data into training and testing and validation. Okay, so how we will do it actually? Okay, how to not you, my man, how to split the data. So what we actually usually do, okay, so let me, for a better understanding, so this is our whole data set. Okay, this is our whole data set. Suppose that this is our data set in which we have 10 instances. Okay, instances. My voice would be, somehow little bit of not, the thing. Yeah, so we have around 10, 1 2 3 4, from 0 to 9, so we have around 10. Okay, so we have 10 rows and 10 columns. Okay, 10 rows and 10 columns, so we have around 100 instances, not it's instance. Okay, instance, not instances, is instance. Okay, let me write it here, instances. Okay, so that is, we have around 100. Okay, so what do we usually do? Okay, so what we do is that we do x train, x test, y train, and y test. Okay, so and we divide this in ratio of suppose that 2. Okay, suppose that 2 squared. So the testing set, okay, that do that when we do our train test split. Okay, train test split, the test size is actually 0.2. Okay, the test size is actually 0.2. So what we actually said is that for the x training, x test, y train, and y test. Okay, so suppose that this is our features. Okay, and this set is for training. Okay, this set is for training, so we'll keep this aside. Okay, now 0.2%, 2%, or we could say that 20%, 20% of data set is for training or testing. Okay, so now split the data set 20%, which means 2. Okay, so we could say that this will be our, so this will be our for, so this is our x train and this is our y train. Okay, this is our x test and this is our y train. Okay, simple, this much data set, this much and this much. Okay, so we'll use this. Okay, we'll use this set for training our model, okay, and we will use this set for, finding the prediction. Okay, and this is what we actually usually do in x train, x test, y train, y test. But now we will have 3 sets. Okay, here we have 2 sets. Okay, now we'll have 3 sets, which is train, test, and valid. Okay, we have 3 sets. So how to do it? Our GPT will help us. Okay, so where do we ask now? Yeah, so you can use the train test function, and this is an example of how to split the train extent and all this is okay. Yeah, so what we have feature, we have target. First step, split the data into training and validation testing. Okay, okay, now the x train, x val, this is x test. Okay, train val. Okay, x test, y train, y test. Okay, as we do for the training or validation. Okay, so previously we have actually divided for the x train and x test, then dividing the test sets into 0.5. okay, 0.5, yeah, means 25% of the data. So let's see the explanation. So train test split x and y test size will be 0.2 and random step 24. Split the data into 80% of training, validation, 20% for the testing. Yeah, training plus validation and 20% for testing. The random state ensures reproducibility. Okay, reproducibility, sorry. Train test split x train val. Okay, yes, 25%. or we could say that 50% will be good, because we don't have much data. Have this and okay. Further split the 80% into 60% and 20% validation set, which means that 25% of 80%. So here now, as I said, so let's try to visualize it. So suppose that we have 10, okay, we have only 10 rows and 10 columns, okay, equal data. And what we used to do is that we used to split it in training and testing. But according to this, we will first split it into training, okay, and testing. For training of validation and the X test, and training and training of validation, Y train and Y test, and then the main training set and the validation set and the main training set and the validation set for the value that we have to predict, okay. So we have to do X train, let's write it here, X train val, okay, X test, Y train val, and Y train, okay. Again, what we'll do is that X train, then X val validation set, and Y train and Y val, okay, that we have to do. So first we'll split our data set into around 0.2, again the ratio of 0.2, the test size will be 0.2, and for this we'll split it into 50%, okay. So test size will be 0.5%, 0.0% man, like 50%, okay. So what we have to do is that into 20%, as we have said. So this will be X train val and this will be Y train val, okay. Now seeing this, this is our X test, the actual X test, and this is our Y test, okay, as we said earlier, okay, as I so Y val, okay, and we will divide it into 5, means 50%, okay. So according to this, we have done all these things, okay. According to this particular code snippet, we have done, I have split the data into X test, Y train val, and X train val, okay. Now we have to keep this aside because we are not using it. This will only be used for the training set, okay. Once we have all this training, okay, so I am keeping this here, okay. Now moving ahead, now we have to split this whole data set, okay, this whole data set, which was our X train and Y train val, into 50%, okay. So we have around how much, 8, I think, where is the K? So we have around 1 2 3 4 5 6 7 8, okay. So now I will split the data set into half, okay, it's half, so it is like this, and we'll split this data set. See, split this data set, okay. Now total of 100%, this data was 100%, we have 40% here, 40% here, okay, we have 40% here, okay, 40% here, and 20% here, okay, 20% here. So this is the data set that we actually going to deal if we have around the 10 rows and 10 columns from the, suppose that it is actually the thing that we are going to divide the data set, okay. So yeah, so this is, now let's name them. This is our X test, okay, and y train, the actual y train, and this is and this is our x val, okay, and this is our y val, okay. Now we will use so I don't know man, but why like these aesthetic kind of thing looks very good, okay. So this very data set will be used for the training, okay. This will be used for training, this will be used for prediction or prediction, okay, and this will be used for evaluation, okay. These are the thing that our data set means in splitting the data into x test, y test, x val, and all those things, okay. So now let's code it. Yeah man, I know this is going very slow, but still I want myself and you also to get understand it very well from the code, that we won't need anything else in the future, okay. So as we have splitted the data earlier, but still now I'm going to wait. Have I done it earlier? No. So now I'm going and I am, you know, I'm just commenting. I'm commenting it, okay. I'm just commenting, not when doing the comment. I don't know like how how the hell I'm speaking, but still, yeah. So I'm just commenting all those things that we don't need. So we need it, but not right now. But still, I need to comment this all. Now let's split our data, okay. So let we comment it, and did I imported the scalar print as split, okay. So let's from sklearn dot model selection import train test split, okay. So white train, not white train, but yeah, white train. No man, white test, not white train, okay. White test train test split, okay. So we'll be splitting this and y x test and our random state 0, okay. Now I will do it in the another cell for finding the data that we have, okay. So yeah, train train trained, why the hell man? Train test split, okay. our x y, okay. Test size 0.5, random state equal to 42. Let's check it man. So I've ran this and let's see if we don't get any error, okay. We haven't got any error. So now let's see the x train, how is it, and we have 7,224 rows. That is a good thing. And let's print all the shape of it, okay. Shape. So okay, so we have 8,256 rows in our X train val, and for the testing we have 256 data. Good thing, data do. Okay, yeah. So we have got all those things, okay. Now moving ahead, we have y test. Yes, y test. Why do we have like 16 columns for y test? X train val, train test split. Yes, X train, X test, Y train, Y test. X train split, random set 42. Okay, no problem. Now this much. Now man, let's see like do we get any error or not after us implementing, we'll see. Okay, now this strain val and y train val. Okay, so do we get an error? Let's see. Yes, we have got an error. Let's see what expected 5 got 4. Okay, still do have 4 here also. Y val test size, no man, we'll not test size but y. Oh yes, y. That's what. Now x train. Okay, shape of x train and x val and y train. Oh yes, man. That's why I thought that why I'm getting error. I actually did here why. That's why I was I was getting here 16 and I confused like why if you have only like this one column why I'm getting 16 column. That is a bad thing. Okay. Now moving ahead, y test shape x train x y train all. Okay. So let's see its shape. Now we have reduced actually what we have here also. X no y val man y val. Okay, y val. Yeah. X train dot shape x validation set y train y validation set. Okay, but here we have 0. No, yes. Oh yeah, from this also. From this we will get half. Okay, that is a good thing. Okay, we splitted the data into, man, it is actually good to split the data into 50% in the both training and testing data set. Let me ask to the GPT. So if so, should we split the data into training and validation set into 50-50 to 50%? Is it a good idea or not? Let me cause man see like if you generally not recommended. Okay, so how much data should we split? 70-80. Okay, 70 is 20-30. Okay, okay, 70% for the training, 15% for the validation, and 15%. Okay, we have in the large data set, so we don't have the large data set, so we won't be splitting in the 50% cause for explaining purpose I have actually split it into 50%. So now I will be actually splitting it into 0.2, 0.3. I should think 0.3 man. 0.3 will be a reasonable thing. Okay, so yeah, I have splitted all the data sets. Now I have all these things. Okay, now could we scale the data set also? Okay, so let's train our models. Okay, so the model that we'll be using. Okay, so the model that okay, I mean I have much time left. Okay, so the model that what is the temperature, man? Oh wow, it's at 75 degree. Actually, it's so hot. My MacBook is getting so heated. Okay, yeah. So what is my, yes, so the algorithm that we'll be using is linear regression. And second one will be SVM. Okay, support vector machine. And let us, so we actually use a linear SMV, but that linear SVC, which is actually a classifier. Okay, so what we actually use is that linear SVC, which is actually a classifier. We don't dealing with classifier. So what SVM should we use for regression analysis? Because SVM is mainly used for classification. Now wait man, what you're doing? Okay, come on man, Give me. What happened? Yeah. Support vector regression. Yeah, man, but tell me, the support vector SVR, okay, SVR, SQL and SVR, okay. So, SQL SVR, okay. So we have SVR here. Let's see what does it tell. Come on, man, I'll kill you. So we have got our site. Now let's see and quickly implement. So before that, let's implement our linear regression before that, okay. Linear regression SVM. So this is our linear regression. Now from sklearn.linear import linear regression, okay. So this is our model 1. Linear regression equals to this, and model 1 equal to fit x train and y train, okay. Y train, got it, we got it. So we have fitted, and now predict, okay. Let's fit. So y, so model 1 prediction. So model 1 dot predict on x valid. Okay, wait. Did some mistake? X val, and here should be x train now. For confirmation x train and here will we have x val. Okay, yeah, we got it. So I will predict it on x val. Okay, x val. So we have predicted. Now we have got our score. Let's see the score, which will be y val with the model 1 prediction. Okay, what is the score? Oh man, sorry, model 1 dot score. Okay, so we have got our first error. That is a very good thing, and congratulate for us. Okay, so this is telling us expected 2D array but got 1D array X instead. Okay, so let's print actually is that model 1 prediction. What we have got 1D array and y val. What is y val, man? Actually, the shape for the y val, we don't have 2D array, man. So let's print the y val, what y val has, and let's see it. What it is, man? What it is? What it is? What it is? What it is? Not marked on, but code, and it should be y val. Okay, y val. Let's print. Yeah, man. This is the thing that we have. Okay. So do we have? Actually, the thing that I have got. The prediction. Okay. Let me take its shape. It's 2477. Okay. And for the y val dot shape, if we do it shape, it should be shame. It is shame. I think it is, yeah, it is shame. Then why we are getting it, info shape info. Uh, y val. Okay. So expected 2D array got 1D instead. Okay. So we had expected 2D, but we got 1D. Array this, reshape your either array to this. Okay, so let's see what its GPT tells us. Okay. Input. This is a very dumb, but still, yeah. Isn't it taking much time? More than expected. By the way, don't need you, my man. Okay. So why should we actually? Okay. Hmm. Okay, so let's do it. Now still we will get error. str. So a lot of things that we have to deal with. Okay, so contain a sample. Okay, so these type of error are very common that we also get. Okay, so I think that I should wrap it now, and I will tell you guys the solution for in the next lecture, the video. And if you have watched it right now, then I think that I haven't much covered in this video. That what I've told actually is that I've actually told about this very concept, the X train, Y train, X test, Y test. Okay, here it should be Y train. Okay, Y train, X train, and then X val, Y val, and X test and Y set. This was actually, the best thing that I told. And yeah, so thanks for watching it right now. And if you enjoyed, just comment below that what you actually enjoyed, and join our Discord, that you'll find more enthusiasts of AI and ML there, and you can go and explore with the people. Okay, so have a great day, and thanks for watching till right now. Bye bye.